Good morning, boys and girls. I'm sorry I can't be in class today. I have a meeting, um, but I do want to kind of make sure that we're staying on track and that we're in the right place. So I created this video so that we wouldn't get too far behind in what we need to do. The homework for tonight, remember, is to read pages 74 to 79 of Chemical Building Blocks. And I made this assignment yesterday. Chemical Building Blocks is your textbook with the salt crystals on the front. You can use your own hard copy textbook or you can access it online. But read pages 74 to 79 and then answer the questions on page 79, 1, 2, and 3, all parts. And this is written on the board as well. Today, what we're going to do is dive in a little deeper and start talking about the structure and function of the atom. Um, you should have in your folder a set of pages that look like this. Um, this is like a note outline for you, and so we kind of put this together so that you wouldn't have to write too much, but more or less you'll be filling in the blanks, um, that are here and open, and just kind of following along as we go through some things. So you will be taking a few notes today, but fortunately, you don't have to write too much. Go ahead and take a minute and find this in your folder. You are also going to get a periodic table today. This is one of two periodic tables I'm going to be giving you. This first one is a small one. Now, some of the things that we need to see on this small one are very faint or light. So you are going to get a second one, which is going to be larger, like a notebook-sized periodic table, and it'll have a lot more information on it. But this one will work well for what we need to do today. And I'll give you a second to go ahead and get the periodic table that you need as well. So you need the structure of the atom outline, and you need the periodic table of the elements. Remember, try as much as possible to be in class tomorrow as well, because we will be talking about the atom model project tomorrow, and I want to make sure that you at least have a good understanding of what the requirements are for that. So try as much as possible to be here. I know a lot of people have been out sick, but if you have like sectionals or anything tomorrow, you might want to kind of reschedule those and try to be in class. Okay, at this point, everyone should have the structure of the atom outline. Everyone should have the periodic table of the elements table, the small one. Put your name on the periodic table of the elements that you've just received, and do that in ink. Put your name on it in ink so that if it's lost, we know who to find, or we know who to give it back to. Okay, so we're going to dive right in, and as we go through, we may be doing a few exercises related to the periodic table. So I'm going to pull up my presentation here, and we're just going to go ahead and start. Okay, so structure of the atom. And so I put a few things in here that kind of go along with what's on your note outline. Um, and once again, all you need to do is just kind of follow along with this. Okay? All right, so I guess the best place to start is just at the beginning. So what is an atom? And basically an atom is the basic particle from which all elements are made. So the basic particle from which all elements are made. Now on your sheet, you probably have like a couple of blanks there. And so all you would do then is fill in the correct words that go into the blanks for your note sheet. So an atom is the basic particle from which all elements are made. Now, when we think about the elements, we typically think about the periodic table, and you have a periodic table in front of you right now. Now, we are by no means going to learn everything we need to know about the periodic table today, or tomorrow, or the next day. However, our study of the periodic table is going to be a gradual progression. We're going to learn some things, over the next several weeks, and our study of the periodic table is going to continue all the way into third quarter through to mid to end of third quarter. And along the way, we'll be learning bits and pieces. So don't walk away today thinking that you know everything about the periodic table, or we're going to learn everything about the periodic table, because we won't. It's going to be a gradual process. However, I did pull this up just to help you understand, at least at this point, that all of the atoms that we know of are represented on the periodic table. Okay, so each box that you see is representative of a different element or a different atom. Okay, so what is an element? Okay, so an element is a pure substance that cannot be broken down into any other substances by chemical or physical means. Okay, so typically when we think of an element, we think of a group of the same kind of atom. Okay, and the smallest thing that I can take from that sample and still have it be that element is an atom. So for example, here is gold. The smallest thing that I can take from this sample of gold and still have it be gold would be an atom. Okay, a group of gold atoms together is considered an element. Okay, atomic number. Now, I want you to look at your periodic table. And again, your periodic table is slightly different from the one I have posted on this presentation. On the periodic table that you have in front of you, if you look in the top right-hand corner of each box, you should see a number. Okay, that number represents the atomic number. Okay, and the atomic number can tell you several things about the atom. It tells you the number of protons. It tells you the amount of positive charge. It tells you the atom, what the atom is. It identifies the atom, and it can tell you the number of electrons. So it tells you a number of different things. Now, the atomic number can be in different places. For different periodic tables, different publishers might put, the atomic number in different places. Some might put it at the top of the box. Some put it at the bottom. Some put it in the middle. But usually the largest number in the box is going to be the atomic number. In this case, like here, in this piece of a periodic table, the atomic number for silver is 47, and that number is located in the top left-hand corner of the box, whereas on the periodic table that you have, it's in the top right-hand corner. I want you to find the element calcium. And I want you to tell me what the atomic number is for calcium. Okay. If you said the atomic number is 20, then you are correct. If you look in the box for calcium, you will see several things. You will see the atom's name. You will see a capital C, a lowercase a, and that's the atomic symbol. Obviously, 20 is the atomic number, and 40.08 is the atomic mass. So this tells us, the atomic number 20 tells us that calcium has 20 positive charges in its nucleus. If we go back, remember it tells us the number of positive charges. It has 20 protons, and then it also has 20 electrons. Okay, remember the electrons are the negative charges, and when we're dealing with neutral atoms, which is what we're dealing with now, you're always going to have the same number of positive charges and negative charges. Now later on, when we get further into chemistry, we'll start talking about what happens when you have a different number of protons and electrons. But for now, we're dealing with neutral atoms, and they're the same. Okay, let's move on. Okay, the atomic mass. The atomic mass. On your periodic table, if you look at the key, and the key is, now they use bromine for the key on your periodic table. Okay, if you look at the key, you should see some arrows pointing to different items within the box for bromine. And then there's a label by each of those arrows. Now, if you look on the right side, the very last label is atomic weight. And the atomic weight for bromine is 79.904. Okay? Now, if you look in that same position for all of the other elements, you should be able to find the atomic mass. So what does the atomic mass tell you? It tells you how much an atom weighs. It indicates the total number of protons and neutrons in the atom. So protons and neutrons, remember, are located in the nucleus. Okay? And so the atomic mass tells you the combined mass of those. 1 proton is equal to 1 AMU, or 1 atomic mass unit, and 1 neutron is equal to 1 atomic mass unit. So that means that they're about the same mass. However, take a look at this. 1 electron is equal to about 1/1835 of an atomic mass unit. So that means that if we were to take a proton or a neutron and divide it up into 1,835 pieces and take one of those pieces, that would be about the size of an electron. So that's very small. All right, let's do an exercise. I want you to find the element iron, and I want you to tell me how many protons iron has. I want you to tell me how many electrons iron has, and I want you to tell me the atomic mass for iron. I'll give you a minute. You can work with the person next to you if you like. Okay, so here's iron, and if you said that iron has an atomic number of 26, then you are correct. As far as the number of protons, it should be 26 because the number of protons or positive charges is the same as the atomic number. What about electrons? The number of electrons should be 26 as well because that's the atomic number. Now, what about the atomic mass? If you said 55.845, then you are correct. Very good. Okay, let's talk about isotopes. Isotopes can be described kind of as sort of like twins, okay? Isotopes are different versions of the same element. Um, Different versions of the same element, and they may have different properties as well, even though they're considered kind of the same element. Um, the masses on the periodic table are decimals because it includes all forms of the element. So that involves the isotopes. When you look at a atomic mass, you'll see a decimal, okay? And it's a decimal because it considers a sample which involves all versions of that particular element. And so when it's averaged out, you end up with a decimal. Isotopes then have the same number of protons but a different number of neutrons. Now, why the same number of protons? It is the number of protons, if you remember, that actually identifies the element. So what makes hydrogen hydrogen? Well, it's because it has one proton, atomic number of 1. What makes helium helium? Well, it's because it has 2 protons, an atomic number of 2. What makes carbon carbon? Well, it's because it has 6 protons. Okay, so the number of protons identifies the element. But there are also these particles in the nucleus called neutrons. And atoms can have different numbers of neutrons, but if they have the same number of protons, it's still considered the same element. Okay, it's an isotope of that element. Let's look at an example. Okay, here's carbon. Okay, we have typically carbon has 6 protons. If you look at the periodic table, you'll find that carbon has an atomic number of 6. Okay, so it has 6 protons. Carbon also has 6 neutrons. If we went through the calculations, we find that it has 6 neutrons in its nucleus. Okay, but there's another version of carbon that has 6 protons, but it has 7 neutrons. It has 1 more in its nucleus. If you count them, you'll see that there are 7. 6 protons. The protons are the orange dots. The neutrons are the blue ones. So over here we have 6 protons and 6 neutrons, but over here we have 6 protons and 7 neutrons. But then there's another version of carbon, carbon-14. It has 6 protons. If you count, you'll see 6 orange spheres, and then you'll find 8 neutrons. Okay, so 6 protons and 8 neutrons. All 3 of these are carbon. They're isotopes, or these two, carbon-13 and carbon-14, are isotopes of the regular carbon. Okay, so they're all carbon atoms, but they're different versions of carbon because they have varying numbers of neutrons. Is that going to change the atomic mass? Well, yeah, it is. Because here, regular carbon has an atomic mass of 12. If you look at the periodic table at the atomic mass for carbon, element number 6, you'll find that its atomic mass is 12.0. But carbon-13 has 1 more neutron, so its atomic mass is going to be 13. Carbon-14 has 2 more neutrons, so its atomic mass is going to be 14. Okay, so different versions of the same element. Okay, let's keep going. Okay, now you've heard me mention atomic mass unit. Okay, the atomic mass is usually measured in atomic mass units. Now, 1 atomic mass unit is equal to about 1.661 times 10 to the negative 24th grams. Now that's very small. Back several weeks ago, we talked about, why it's important to use, you know, um, the appropriate units and the appropriate tools to measure and quantify small things. Okay. Well, this is one of the examples, or one reason why. Um, when we're talking about subatomic particles, it's very, very impractical to use grams. Okay, if we had to use grams, then we'd come up with a number that looks like this number that's at the bottom here, or we'd have to write it in scientific notation like it is at the top. Okay, so instead we use atomic mass units. Okay, so the atomic weight is expressed in terms of atomic mass units. Okay, this is a very, very important part. How do you find the number of neutrons in an atom? How do you find the number of neutrons? Now, the number of neutrons, first of all, let's go back. Protons, neutrons, and electrons. We find the number of protons and electrons by looking at the atomic number. Okay, if the atomic number is 20, like for calcium, I'm going to go back. If the atomic number is 20, then that means that we have 20 protons and we have 20 electrons in the atom. But what about neutrons? How do we find the number of neutrons? To find the number of neutrons, it's basically this. We round the atomic mass to the nearest whole number, and then we subtract the atomic number. So we round the atomic mass to the nearest whole number, and then we subtract the atomic number. Okay? So for calcium, it says find the number of neutrons for calcium. The atomic mass for calcium is 40.08 atomic mass units. So if you look at the periodic table, find element number 20, you'll see 40.08. Actually, what you see is 40.07, and it's been rounded to 40.08. We round that to 40. Why do we round it to 40? Well, if the number to the right of the decimal is less than 5, then we round down to 40. If this number to the right of the decimal had been 5 or greater, we would round up to 41. But it's not, so we're going to leave it at 40. So once we get to 40, we then have to subtract the atomic number. The atomic number is 20, remember? That's the red number. So rounded atomic mass minus the atomic number, 40 minus 20, that's going to give us 20. So calcium has 20 neutrons. Okay, let's do an exercise with a few more of these. All right, I want you to look at your periodic table. I want you to find the element aluminum. Find the element aluminum. Aluminum is element number 13. I want you to find the number of protons. I want you to find the number of electrons. And I want you to find the number of neutrons for aluminum. So we want protons, electrons, and neutrons. I'll give you a minute. Talk with your partners and figure this out. Use your periodic table. Okay, aluminum, element number 13. Okay, so what again does the atomic number tell you? The atomic number 13 should tell you two of these answers. If you said that the atomic number tells you the number of protons and electrons, then you are correct. Aluminum has an atomic number of 13. So that means that the number of protons is 13. That also means that the number of electrons is 13. Okay, now how do I find the number of neutrons? If you remember, the number of neutrons equals the rounded atomic mass minus the atomic number. Okay, so what is the rounded atomic mass? The atomic mass given on the periodic table is 26.9815. Now, do we round that up to 27 or do we round down to 26? The number that's to the right of the decimal is 0.9. So that means we're going to round up to 27. So the rounded atomic mass is 27. We're going to subtract the atomic number, which we already know is 13, which is right here. That means then that our number of neutrons is 14, because 27 minus 13 gives us 14. So our number of neutrons is 14. Let's do one more. I want you to look at your periodic table, and I want you to find the element titanium. Find the element titanium. Find the element titanium. If you're looking at your table, you should find that the atomic number for the element titanium is 22. I want you to find the number of protons. I want you to find the number of electrons. And I want you to find the number of neutrons. Okay, so if you said that the number of protons is 22, you are correct. If you said the number of electrons is 22, you are correct. Now, what about neutrons? Okay, remember we have to do a calculation for that. And same as up here, neutrons equal the rounded atomic mass, minus the atomic number. So when we look at our periodic table for titanium, we find that the atomic mass is 47.867. So do we round up to 48 or do we round down to 47? Well, I see 47.8. So because the 0.8 is greater than 0.5, I'm going to round up. So I'm going to use 48. So the rounded atomic mass is 48. We're going to subtract then the atomic number, which we already know, up here is 22. So then what is our answer? If you said 26, then you are correct. Okay, the number of neutrons is 26. Very good. Okay, let's do a couple more things and then we're going to stop for today and we'll continue and finish up tomorrow. In the nucleus, you know that it contains both the protons and the neutrons. It's located in the center of the atom. And so this should really be kind of a review. Protons have a positive charge by one positive electrostatic charge. They're found in the nucleus. They weigh 1 atomic mass unit, and they determine the identity of the atom. Okay, so those are all things that we have kind of talked about already. What about neutrons? Neutrons have no charge. Okay, so protons have a positive charge, neutrons have no charge. But they are found in the nucleus. They have a mass of 1 atomic, or they weigh 1 atomic mass unit. The interesting thing about neutrons is that they are responsible for radioactivity. Okay, neutrons can be spontaneously released in nuclear decay. This happens more frequently in large unstable atoms, and we're going to get into radioactivity later, and we'll actually do a radioactivity lab which allows you to actually see trails left by these particles as they leave the nucleus of an atom. But neutrons are responsible for radioactivity. Okay, so this is just a visual. Neutrons can be released. A lot of times they're released along with protons as an alpha particle, like in this case, 2 protons and 2 neutrons. And sometimes there are some conversions that take place between protons and neutrons in the nucleus, and then a negative beta particle is released, which is like 1 electron. Okay, on to quarks and gluons. Okay, we're almost done. I think we've talked about what makes up protons and neutrons already, so this shouldn't be totally foreign to you. This is an example of a proton. Okay, protons are made up of up quarks and down quarks. There are 2 up quarks in a proton, and there's 1 down quark. Now, how do we get the charge of +1? Well, that's because up quarks have a charge of positive 2/3. Down quarks have a charge of negative 1/3. So when we add those together, if you have 2 of the 2/3 charges and 1 of the negative 1/3, you're going to get 1. So that's where the 1 comes from. Now, what about a neutron? Neutrons have 1 up quark and 2 down quarks. Okay, so it's just basically a matter of adding the charges. You have 2 negative 1/3 charges plus 1 2/3 charge, and you're going to get 0. Okay, so protons, 2 up quarks and 1 down quark. Neutrons, 2 down quarks and 1 up quark. Notice the color differentiation here. Over in the proton, the up quarks are colored purple, the down quark is green. Over in the neutron, the down quarks are green and the up quark is purple. You'll have to do the same thing in your atom model. You'll have to make sure you differentiate between the types of quarks in at least 1 proton and 1 neutron. If you look at the model that's hanging in the center of the room, you'll see that that is the case. Okay, this is our last slide for today. Electrons. Electrons are negative. They have a charge of -1. It's a -1 electrostatic charge. And that's kind of what holds the electrons near the nucleus is that difference in attraction between the negative electron and the positive nucleus. The electrons orbit the nucleus. Now, in one of the models, in the main model of the atom that we're looking at, the electrons orbit the nucleus in up to 7 energy levels, or shells, or sometimes they're called orbitals. They weigh they weigh 1/1835 of an atomic mass unit. I think we talked about that already. And then they're also responsible for chemical activity and chemical bonding. And we're going to get into chemical bonding a bit later, but electrons are responsible for that. Okay, one more exercise. I want you to look at your periodic table, and I want you to find the element gallium. Find the element gallium. I want you to tell me, for gallium, I want you to find the atomic number. I want you to find the number of protons. I want you to find the number of neutrons. Electrons. I want you to find the number of neutrons. I'm going to throw one more thing in here. Atomic number, and I also want you to put in the atomic mass. And I want the rounded atomic mass. Okay, I'll give you a few minutes. Gallium, if you have not found it, is element number 31. Check the desk. Okay, you should be done. The atomic number for gallium is 31. The atomic mass, let's look. On your periodic table, it says 69.723. So in this case, do we round up or down? Do we round up to 70 or do we round down to 69? We would round up to 70 because the number to the right of the decimal is 7. And so it's 5 or greater. So we're going to round up to 70. Okay, how many protons does gallium have? If you said 31, you are correct. How many electrons does gallium have? If you said 31, you're correct. How do we know this? We know protons and electrons are the same as the atomic number in a neutral atom, and we are dealing with neutral atoms at this time. How many neutrons are there in gallium? Okay, we know we need to do our calculation, so let's do that. Um, we take the rounded atomic mass, which is 70, and we're going to subtract from that the atomic number, which is 31. And we should get 39. 70 minus 31 gives us 39. So the number of neutrons is 39. Okay, so that concludes our lesson for today, boys and girls. I hope you learned quite a bit. Tomorrow we're going to talk about subshells, um, which gets a little bit more difficult, but I think you can do it. And I look forward to jumping into that with you. Take care.